Good afternoon to you all. I am hoping that you can hear me. My name is Laura Lacey and I'm going to chair today's event, which I'm hoping you'll find really interesting. I'd now like to present our guest speaker for you today. I have the pleasure of introducing Dewar Donnithorne-Tait. He was born in Edinburgh, Scotland, and after Dewar attended Christ College, Cambridge, studying nautical science and doing research in applied biology. He's also been involved in unmanned systems since 1983 and was a board member, vice president, president, and chair of the Association for Unmanned Vehicle Systems International in Washington, DC. He started flying unmanned aircraft commercially in the UK in 2007. He was a founding chairman of the Royal Aeronautical Society's Unmanned Aircraft Systems Specialist Group, and for 10 years was secretary and then chairman of the EUROCAE UAS working group, developing standards for unmanned aviation. He's married with 3 grown-up offspring. He is passionate about wildlife conservation and unmanned systems and travel and photography. So, Dewar, I'd like to hand over the floor to you, please.
Well, thank you very much indeed. I shall now set about trying to share my screen. Good.
I can see your slides.
That's excellent. Thank you. This is the title slide. I thought to point out right at the start that I'm not an airworthiness practitioner, and therefore I probably will say many things which would be considered sinful in this community. I started my involvement with unmanned systems with unmanned ground vehicles in 1983 at the Royal Military College of Science, but then became involved in unmanned aircraft systems in '93 when I was working in the embassy in Washington. Having been in the sector a long time, I actually set up my own business called Adfingo and flew commercially from 2007. But quickly I was sacked off to run a project in Canada for commercial exploitation of UAS. As already said, I've been around many groups in the sector, but the sort of key points relevant to this presentation is when I was in EUROCAE's UAS working group, subgroup 2 focused on airworthiness, and I attended some of their meetings, and I realized that the people attending these meetings had come from the manned aviation airworthiness background, and as a result their view of the certification basis was founded on protecting human life aboard the aircraft, and more of that later. I also discovered, as we were discussing a few minutes ago before the meeting started, I've been involved in trying to come up with a basis for qualification and classification of unmanned aircraft systems. And I found that quite hard, so I gave up. And instead, I focused on how do you assess operational risk. And I came up with a mathematically rigorous approach, which I presented in Madrid in March 2013. And that paper was a working paper that got more fully developed. But clearly, even if it was mathematically rigorous, the results would always be probabilistic. And one of the contributors to that probability was the aircraft itself and its airworthiness. So the starting point, the people I used to work with in EUROCAE, the airworthiness regime has evolved for more than 100 years. However, we know that you can tailor the requirements depending on the certification basis, whether it's for commercial aviation, for rotorcraft, for general aviation, other forms of aviation. However, throughout this 100 years, the principal focus has been on airworthiness to protect human life on board the aircraft. Now, by doing so, you automatically mitigate third-party risks to a large degree. The aircraft falls out the air, you might kill somebody on the ground, but you'll probably kill people in the aircraft. Ditto hitting another aircraft. Another key point that in order to achieve the very high levels of safety which we currently do achieve, certification is a long and expensive process. And that means almost without doubt that the aircraft have to have fairly long service lives. So the costs of the certification process can be amortized throughout their service life. However, I'm talking about current unmanned or uncrewed aviation, and I'm happy to discuss terminology later, but it's a long and tedious subject. So I'll be using UAS in several definitions and RAeS, remotely piloted. Current unmanned aircraft don't have a human pilot on board. By and large, they are, according to ICAO and several regulators, they have to be remotely piloted. But we know that there is already a capability for fully automatic flight. And once again, I'm avoiding the use of the word autonomy. Also, at the moment, there are no human passengers on board, although consideration has been given to things like search and rescue missions, where a person who's already in danger might be recovered by an unmanned aircraft or drone. But apart from that, there's no risk to human life on board. And that's an interesting one. It means that the only risk is to third parties in the air and on the Earth's surface. And when you consider the implications of that statement, you realize that the risk is dependent very largely on the operation environment, and therefore it's extremely variable. There's no one standard for airworthiness. There's not, or there's no standard for protecting human life on board the aircraft involved. It's about protecting against third parties. So mitigation arrangements should be tailored to meet the safety requirements, that's the first requirement, but as economically efficiently as possible. Gold plating over-insuring for the particular operational scenario reduces the economic efficiency and business case for the operation in mind. The other thing to consider, because of remote piloting and other aspects, airworthiness in consideration of unmanned aircraft systems needs to adopt a full system approach. And clearly the aircraft itself, the likelihood it will fall out the sky, the likelihood it will not hit other aircraft, very important factor. But communications, since there's remote piloting, there have to be communications. At the moment, for those aircraft that ICAO wish to consider, the ability for a human pilot to intervene at any stage is a requirement for those that they're considering. But we know that, for example, with VHF communications, you're very lucky to get better than 95% availability. You can do with redundancy, but you have to assume you will be losing the link. And so therefore, those lost link procedures feed directly into the airworthiness of the whole system. Similarly, the remote pilot station, and there may be more than one, there may be pilot handover. The reliability and availability of the tools and systems in the remote pilot station have to be considered, as well as any antenna arrays that might be deployed for use in the system. There's much debate, which is still unresolved, about the nature of what's called detect and avoid systems, and many of you will be familiar with these issues. Remote piloting with the pilot in a remote pilot station assumes a degree of latency. And therefore, there may be a point, if a potential conflict is about to happen mid-air, that the system would better react automatically than to wait for the pilot response. And I say there's a big debate, and it's a different issue. But it means also, if we're talking about safe navigation of an aircraft in the airspace, the quality of service delivered by the detect and avoid system plays directly into a wider consideration of the platform's airworthiness. Larger unmanned aircraft take off and land pretty much like general aviation and larger. I mean, Global Hawk is a 10-ton unmanned aircraft. But smaller platforms, including the ones I operated, were launched using a system and recovered using a system. And similarly, these aspects ought to be considered as part of a full system approach. Luckily, software assurance now is fairly widespread and fairly well known. And I think as long as we limit ourselves to the prescriptive, if you like, automatic but not autonomous, in other words, the system can't change its own rules, I think much of the software assurance measures will apply. And really up to this point, and I'll take a step aside, that in the future, and I'll return to this later, there's every likelihood that unmanned aircraft, especially those operating at low level, but that's also be decided, might be controlled in flight, have their trajectories decided by an unmanned traffic management system and its surveillance bits. And I'll return to that point. So airworthiness tailored to meet specific operational risk and safety requirements depending on the business case and the levels of safety required. By and large, excuse me, if you're dealing in an area with high air traffic and local population density, you will have to have high levels of mitigation and arguably probably at very similar levels to existing rotorcraft and general aviation, and in some cases perhaps even commercial aviation. However, if you're doing polar bear surveys over northern Canada, or indeed another of my customers when I was in Canada, wildlife, deer, mainly elk surveys in a large area of diamond mining in northern Alberta, there's almost no air traffic and almost no population density. And so systems operating in those situations don't need to have the same levels of mitigation. And it's really all about meeting the safety requirement as economically efficiently as possible. And there's no one standard. And in my experience, this is something quite new and quite interesting for the airworthiness community. And we have to remember also that some operators, one of my colleagues on the specialist group here in the Aeronautical Society, he flies, he constructs and operates really quite affordable and very effective unmanned aircraft. But the payloads, imaging payloads, are really very expensive. So while you might be operating in a remote area and the risk to human life is very low, operators may wish to buy an unmanned aircraft, which is unlikely to fall out the sky to save the cost of their equipment. And really, it's not just the unmanned aircraft, but all systems involved, all parts of the system together. The levels of mitigation need to be combined to meet the safety requirement, but effectively. And communications needs to be worked on. SATCOMs are widely used, as we know, but all communications are problematic. And as I said, there are many issues involved in detect and avoid, even the specification and the fundamental requirements that are still not agreed. And how do those unmanned aircraft detect and avoid capabilities interoperate with the rest of the air traffic management regime? So far, almost all I've said is in the context of current ATM. However, you can imagine that if Amazon starts making widespread use of delivery aircraft, and indeed many other companies, and law enforcement, environmental monitors want to use the airspace, especially over cities, there's going to be a very high density, potentially, of unmanned aircraft system activity at low level. And of course, the key point about low level is in many cases, there is no air traffic control. I mean, a lot of Class G airspace, you don't get ATC services. And of course, in urban areas, there's a huge amount of clutter and obstruction and multipath and wind channeling. So it's an incredibly complex environment. So the idea is to have an automatic unmanned traffic management system that will do flight planning, do the trajectories, taking all these factors into account, and to give the flight paths, indeed, to the unmanned aircraft during flight. And this, of course, requires comprehensive surveillance. And the assumption this will be highly automated, in many cases, people are talking, and this comes from the ICAO Drone Enable 4 conference last year, that the UTM system will be fully automatic and will be instructing the aircraft second by second as to what to do. This means that the UTM system itself is, if you like, responsible for the safe flight trajectory of the unmanned aircraft. And there is no doubt that it will need to be certified in some way to make sure that it provides the required quality of service and therefore safety assurance. And then, of course, there's the question of, we're dealing at low level, and I don't want to get into technical terms of what that might be, and 400 or 500 feet, might be the existing, or 400 feet, I think, CAA term. I know in my operations, I had to seek permission to fly at 800 feet because that was ideal for my system for doing terrain surveillance. But I got permission for it. But as soon as you start going above that 400 or 500 foot level, you start conflicting, or should I say, entering air traffic management regime, where there's general aviation, commercial aviation, and rotorcraft. Of course, you have to remember rotorcraft in particular pop up and down at the lower levels frequently too. So there's the question of, how does UTM and ATM work together? Clearly, there'll have to be initial interfaces, and then some people say integration is inevitable, but GUTMA, the Global UTM Management Association, I've heard one of their senior members say that the cultures are so different, he doesn't see integration being possible. It will have to be an interface. But that's a fascinating area to examine later. So, certification. The point I made earlier, and I said I'd return to it, is that the current regime really looks at an expensive and lengthy progress to certify, to give type certification for the type of aircraft which will have a long service life. However, we're seeing at the moment, and over the last 15 years, that the RAeS, UAS world have been exploiting newly developed technologies. Every year, their upgrades, their new technologies, their new ideas, and their new systems. And the question then is it possible to certify something like this? I mean, how would you approach it? So that really is an important question, and it's on my summary chart at the end. In terms of operational approvals at the moment, EASA and the CAA and several other countries, USA and Canada, have adopted a sort of three-group approach. The open category is for small and relatively potentially harmless systems, toys, recreational ones. DJI makes 1 million a year of these platforms. And if you conform to the basic regulations, that's it, you can go and fly. And you can't fly in some areas. It's all in CAP 722 and other regulations in Britain in the CA issue. But the open category means you can go to a shop, buy one, you follow the regulations, and you can go and fly. Specific, and this is where the vast majority of commercial UAS operation is now, is where you've got a platform that's heavier than 150 grams or whatever the relevant national weight limit is. And there's a need for the authority to make a standard operational risk assessment. This is known as a SORA, and JALIS have been developing a SORA methodology for some years. And this means basically that the operator must go to the authority and describe the nature of the operation, describe the intrinsic operational risk of where it is, air traffic, population density, protection of the population, a range of factors, and then demonstrate how his system or her system, the operator system, mitigates to meet what the authority said is the safety requirement. And this is really where the airworthiness assessment of a serious professional system needs to be carried out. And of course, doesn't have to be gold-plated, but it has to meet the requirement. And the vast majority of work is in the specific category. many authorities, many individual groups are developing scenarios so that instead of doing a specific operational assessment from scratch every time, if it falls within a scenario, then it can be assumed that some of that scenario is applicable to that operation, which reduces the time and cost of that assessment. However, there are some companies, which I won't mention, who are working towards a fully certified system. And the aim of the fully certified system is that this aircraft can behave, to all intents and purposes of this aircraft system, like a helicopter, like a manned general aviation aircraft. In other words, it can fly over built-up areas and behave like other aircraft. The final sort of thing to consider before looking at the scenarios is the whole question of advanced air mobility, also called urban air mobility. Urban air mobility is taken to mean within or adjacent to urban areas and the suburbs. Advanced air mobility is intercity, so from London to Birmingham, for example. And this means there might well be a different height profile, not necessarily, but more likely a need to go into higher elevations. And current thinking, it envisages probably electric air taxis, Jetson style, with about 6 passengers, operating mainly at low levels between and within urban areas. At the moment, we have helicopters doing that, so we already have a rotorcraft solution with a human pilot. But they're also considering not having human pilots on board, but having unmanned aircraft piloting, but with a human payload. It's envisaged these will be mainly low-level operations. Low-level, as we've discussed, maybe more than the 400 or 500 feet some nations use as a definition at the moment. And so that will require consideration. A key point is that to be operating alongside RAeS, UAS or drones at low level in and around urban areas, there will be these air taxis. And we've already discussed the possibility of a high density of unmanned aircraft, especially in an urban delivery area. And adding to this, taxis carrying 6 people taking on and off from specific sites is an interesting thought. It does assume, urban air mobility, advanced air mobility does assume a UTM ecosystem by which the trajectories of all these various types of aircraft flying an area will be deconflicted and it will be made safe. But a key point of advanced air mobility and urban air mobility is the airworthiness needs to be of a level to protect human life on board, which is a very traditional and well understood requirement. One person, once I mentioned the name, at the ICAO Drone Enable 4 conference last year said that urban air mobility, advanced air, will be at least as safe as commercial aviation. As I say, I'm not an airworthiness practitioner and I really shouldn't comment, but I think that's an extremely ambitious statement and I wonder how it's going to be met. So to conclude, and I won't dwell a lot on this to give time for discussion, I've created, if you like, 6 scenarios to describe the sort of things which might be considered at each stage. The first is where we are now just with RAeS. And I won't read all this out to save time, but obviously there's no human life on board, full system approach, needs to integrate with existing ATM, but it's the intrinsic risk of the operational scenario is a major factor. Excuse me. This is being worked, extensively worked. There are lots and lots of unmanned aircraft flying at the moment, but at the moment there is no low-level air traffic management system. And also in the current environment, there are rotorcraft taking off from London heliport and flying around, so they're already sharing the airspace at low levels with unmanned aircraft, albeit at very, very low densities, because at the moment, very few unmanned aircraft are allowed to fly over built-up areas. But this scenario also already exists, but not at the densities of operation that we're considering. However, if we do move towards unmanned aircraft carrying passengers in the current ATM, these are the factors to be considered. Excuse me. Yeah, thank you. Then, of course, we move into the area where UTM is being implemented. And so aircraft now have to integrate and be interoperable both with ATM and UTM and any interface. And the key point here for me, I think, is probably the second last bullet. And this is this question of, is the UTM system to be part of safe navigation of the aircraft, and is it part of airworthiness, or is it a separate issue? And how do you come up with an overall risk assessment and safety assurance level? And indeed, how do legal and insurance entities do the same? Especially if you have several service providers for UTM. And this is worth debating also. There's nothing wrong in principle of having several UTM service providers in an area. Certainly in different areas, different cities, there's no reason why there shouldn't be different service providers. But the key point to me seems, what's the common operational picture? People can't work to different operational pictures, though there will be some difference because of latency. But how do you ensure that you have everyone using the same operational picture, one version of the truth? So that's an interesting topic. And then this is what's happening currently, as I mentioned on the second slide, with manned aviation doing the human taxi bit. But of course, they'll now be working in an environment where they also will have to integrate with the unmanned traffic management system ecosystem, and integrating and avoiding and working with unmanned aircraft in urban areas. And this is going to be a very different step forward. And once again, there's an interesting relationship between air traffic management, unmanned traffic management, and airworthiness. Where do the borders lie? Where do the borders lie? And the same quality of service issues. And then finally, we have the possibility of having a non-piloted passenger carrying aircraft. And these are the sorts of considerations that have to be made. I don't think I need to make any further comment. These slides will be available after the presentation. So in a summary, we are already working with a full system approach to airworthiness of UAS. We are working at the moment with no human life on board, so only third-party risk. And we are looking for specific operational approvals based on the intrinsic risk and the system mitigation. If we are looking towards not specific approvals, but certification and type certification, how do we deal with much shorter service lives and indeed system refreshes in different parts, whether it's the pilot station or communications or on the aircraft? And the question of UTM certification, is this airworthiness or is it air traffic control? And air traffic management hasn't been certified in the past, so that's going to be an interesting step forward. And then this question of, is integration with ATM going to happen? Is it essential? Can it happen? Is there going to be resistance to it? And how can the interfaces be managed between those two? And then, of course, the final question, and the fundamental one, if we are going to have air taxis, using unmanned aircraft systems in particular, with all those I've said about it before, how can we address airworthiness in that environment? So I've spoken for about half an hour, which should leave half an hour for questions.